Today we're going to learn about exponential and logarithmic functions. Logarithms are actually going to be inverses of an exponential function and is read as the following. Log base b of x is equal to y. That is true only if b to the y is equal to x. Now, our brains think only in exponentials. Our brain does not think in logarithms. So it's super important that we translate every one of our logarithms into an exponential function. How do we go about doing that? Well, it's a very easy concept. What you're going to do is you are going to take the base, which is the number 8. You're going to look across the equal sign, and that becomes your exponent, and then you're going to make that equal to 32. So how do we go about actually calculating this? Well, now I need your brain to think about the number 8, and you're going to say, how can I rewrite the number 8 with a base of a number to a power? So what do I mean by that? 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8, which means 2 cubed is the value 8. How can I rewrite 32? Well, if I take 2 cubed, which is 8, multiply it by 2, that gives me 16. Multiply that by 2, that gives me 32. So this is 2 to the 5th. Now, these two are a power to a power, so you multiply those exponents. And now that my bases are the same, you cross those off, and you have 3x is equal to 5, and you simply solve. Divide both sides by 3, and you get 5/3 is equal to x. Same concept. Let's write this as a logarithm. So this is not, as an exponential. This is equal to x because it's not equal to anything. So we're going to find the base of the logarithm, which is 5, and that becomes the base of the exponential. I go across the equal sign, and that becomes your exponent, and that's going to be equal to 125. Well, 5 is already as small as it can go, and then I'm going to have 125. Well, if I have 25 times 5, that's 125, and 25 is going to be 5 times 5. So that means this is 5 cubed. So now that my bases have the same base, I can go ahead and cross those off and set my exponents equal to each other to give me x is equal to 3. Okay, next one. Same concept. Set this equal to x. So then we're going to go ahead and find the base. The base is 4. Look across to grab the exponent across the equal sign, and that's going to equal the big number 32. Well, we learned before that 32 is 2 to the 5th. That's fresh in our brains. And 4 is going to be 2 squared. This right here is a power to a power, so you multiply. Then, because the bases are the same, you cross them out, and you set the exponents equal, and you divide by 2. Okay? Over here, set this one right here equal to x. Find your base. Your base is 64. So 64 to the x is equal to 1 over 32. Well, what do we know 32 to be? We know 32 is going to be 2 to the 5th. So if 32 is 2 to the 5th, then 32 times 2 is going to be 64, so this is 2 to the 6th. Then, right here, we multiply those exponents together to give you 2 to the 6x. And this is currently in the denominator, so I'm going to move it to the top by making it become a negative exponent now. Now my bases are the same, and I simply set the exponents equal. So now x is equal to negative 5/6. Okay. The common log. Same exact thing, except for a common log has a base of 10. So I'm still going to write this as an exponential. So this is 10 to the x is equal to 1,000. Now, a common log says that I don't technically need to have the base of 10. So if you see just a log of 1,000, that is understood to have that lovely little base of 10. That base of 10 is not needed to be written. It is understood to be there. And as we all know, it can go away. Okay? So if you see log of 1,000, that is the same thing as log base 10. Okay? Now, 1,000 is going to be 10 cubed. So my bases are the same, so I have x is equal to 3. Now we're going to go backwards. We're going to write this as a logarithmic function. So what is the base of this exponential? It is a base of 10, so I'm going to write the word log, and then I'm going to put 10 in the little part as a subscript, and then I'm going to write an equal sign, leaving a space, and this is going to be the number 2, and I'm going to have 100 written as the big number. Now, we're not going to evaluate this after we've written the exponential as a logarithm. We are simply just going to leave it as a logarithm, understanding that our brain works better whenever we are actually using an exponential, not a logarithm. So again, let's rewrite this exponential as a logarithm. So what is the base of this exponential? It is a 6, so I'm going to have log, and then 6 is going to be at the subscript at the bottom. I'm going to leave a space and write an equal sign. The exponent is going to be what it's equal to, and then I'm going to drop down the number 36 as the big number. Again, this is done, and that's all you have to do. Okay, write an exponential function as a logarithm function. So, still exactly the same thing. The base of this exponential is a 3, so this is log base 3. Leave a space, the exponent is 0, and the number 1 goes there. Same thing over here. My base is going to be 2/3, so this is going to be log. Subscript is going to be 2/3. Leave a space is equal to the exponent 3, and then 8/27 is what you're going to put right there. Now, E squared is 7.39. So how do I write this one? This is going to be log base. E is going to be my base of E. I'm going to leave a space, put my exponent here, and I'm going to have 7.39. Now, this right here, every time you see a log base E, it's what we call the natural log. And anytime you see that, it's actually going to be replaced with the letters LN, and it stands for natural log. Yes, I know it's reversed, but that's just the way it is, and this is equal to 2. So those are the letters you are going to use. So tonight's homework is 7-3 worksheet 1.